We're now in the setup part of the project, and you can see if we just move this window, um, we have completed the geometry, we've completed the model, and now we're in the setup. Those little green ticks suggest that everything is okay so far. So there's two main pieces we're going to look at here. The first one is analysis settings. So when I'm in analysis settings, you can see various options around step controls and solver controls and 5 or 6 more different options down there. So I'm not going to spend too long on them, but basically what they do is they allow you to define the solver behavior, the load stepping, maybe convergence criteria. It's essentially how the model approaches the problem from a mathematical perspective. So I'll just show you 1 or 2 of them here, and then we'll move on to creating our supports and our loads. So the first one would be around step controls. So that defines how the loads are applied in increments. It's very, very useful if you're looking at nonlinear problems, maybe for a really large deflection or plasticity or something like that. For a small linear beam deflection like this one sub-step is enough. If you were looking at larger deflections, you might need more sub-steps to ensure convergence. Underneath that, you'll see solver controls over here. So you've got large deflection is off. If you had a large deflection, obviously you need to turn that on, and you can mess around with the convergence criteria, etc. below. So we're going to look at our forces and our supports. So the first thing we do is we're going to create a fixed support, and once we create that, it's asking us where do we want it. We're just going to select the node, which is the end of the beam here, and we're going to apply that. That means that end is now fixed. We're then going to create a load of some sort. So if I hit the little drop down menu here, you see various options. We're going to apply a force. Again, it's asking us the geometry that we're going to select. So if we wanted to apply a UDL or a point load, depending on your requirements, in this instance we're going to apply a point load at the end of the beam like this, and then we got to tell it what is the magnitude of that load. So we have 2 options here. We can define it by a vector, which is relatively straightforward, or we can define it by components. So if we select components, you'll see we want the load acting in the negative y direction. So we don't want any x or z, so we're just going to select the negative y direction, giving it a minus value, and we're just going to go with maybe 2 kilonewtons. And that should be enough information to proceed to the solution component part of the model.